All right, hello everyone, and welcome to my channel. This is an educational channel, and we focus on great theories of everything, ancient and modern, and try to do a deep dive into them so that you can determine how you can best use them to help you with your paradigm shifting or your awakening to 5D consciousness, your formation of a holistic worldview, and just in general, healthy living, mental, physical, and spiritual. So today is our 503rd video that we've done on the reciprocal system of theory. And this is a generalized theory of everything from Dewey B. Larson. Mr. Larson was an American engineer who lived in the 20th century. He died in 1990. Before that, he put out a dozen or so books and many articles and other talks, and he had many associates. Not that many. This is not a popular theory. I don't know, there's not a whole lot of activity on the internet anymore, or if ever, on this. But in 1959, Mr. Larson proposed his two fundamental postulates about how he believed the universe operated. And then from there, he derived a theoretical universe, what his universe would look like if his postulates were correct. And then compared his theoretical universe with the actual universe of our, at least the measured universe of the legacy scientists that they had, put together from all kinds of laboratory experiments and compiled in scientific tables. We have the results of one of those studies here. Basic Properties of Matter is the name of the book. It's primarily on chemistry. We are about to get to the end here of chapter 17, that is on ionization. And I think we're going to try to wrap that chapter up here today and then maybe move on to the next chapter, chapter 18, which is called The Retreat from Reality, which is kind of stuff that Larson writes that I really like, where he gets into the history of science and shows many of the legacy science's foibles along the way. Now, if you want a thorough rundown of how the reciprocal system operates, I wouldn't say thorough, but at least semi-thorough rundown about how the reciprocal system operates, then you want to watch one of my first 474 videos on this topic, and then maybe come back, because this video will basically be assuming that you have some type of working knowledge of the reciprocal system. I will go over the two postulates here. Larson is one of the few scientists who embraces the idea of a universe made out of motion, not matter, not energy, but motion. And in particular, Larson is referring to a kind of motion that he calls scalar motion. Scalar motion is a motion that has a magnitude, but it has no specific direction. You can envision a scalar motion using a balloon that you put dots on with a magic marker. If you blow up the balloon, all the dots will be moving away from one another. They will be moving outward in every direction, no specific direction. Every dot will be moving away from every other dot. And if you contract the balloon, every dot will be moving toward every other dot. Again, a scalar motion with no specific direction, only magnitude. And that outward motion, Larson refers to that as the progression. You could also think of that as anti-gravity. And the inward motion is gravity. Basically, that outward motion is what Larson calls the progression, and that is really the source of everything in the universe. It is not. It is nothing. It is nothing in the universe, but it provides the source for manifestation by basically converting that outward motion into an inward motion through the reversal of that motion. That is the beginning of manifestation. So once it becomes that inward motion, gravitation, then there is inherently matter there. Anyway, that is one difference that is made by Larson in his kind of attempt to construct a universe based on motion. Another is that he defines motion in a different manner as the relationship between space and time. This implies a reciprocal relationship. Motion is basically a fraction, with space or time as the numerator and time or space as the denominator. So, for example, the most basic motion that we may know of is speed. The runner is running at 10 miles per hour. 10 miles of space in 1 hour of time. Space over time is speed. But in a universe of motion, all scientific phenomena are forms of motion. So matter is a kind of motion. Energy is a kind of motion. Force is a kind of motion. Acceleration is a kind of motion. And they all have their space-time fraction signatures. So, for example, matter is time to the third power over space to the third power. And energy is time over space. Matter, force is time over space to the second power, and so on. So this also works very well as a check, to be able to kind of check your units. We can discard the MKS system or the SI system or whatever other system of units, because this system only operates with two variables, space and time. And Larson's first postulate basically states the case of what he's contributing to this system, his reciprocal system, what he's contributing to science or whatever, and then the second postulate kind of states what the scientific background is that he is applying his first postulate to. So the first postulate states that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. And then the second postulate is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. And so Larson takes that first postulate and then he plugs it into, the rules of mathematics, the rules of geometry, the rules of logic, and arrives at a theoretical universe that he then compares with the measured universe of the legacy scientist. Larson has many books on many topics. We have gone over books that he's done on metaphysics, including philosophy, religion, and psychology, biology. Also, he has books on atomic physics that we've gone over, astronomy, not so much yet. And we're going to go over one of his books on economics coming up here pretty soon. So when we go over this work on chemistry, it's not so much to, isolate or focus on the aspects of chemistry that he's getting at. That might be interesting to some people, but it's really more broadly to look at Larson's method and his procedure and his approach to applying this theory of everything to a specific subject. so that you can kind of glean how to eventually be able to apply Larson's theory to your subject, whatever subject that is that you're interested in delving into. The reciprocal system can be applied to anything. So that's the key, is that we are trying to figure out how the reciprocal system works so that we can plug it into whatever subject we want to. And I think that by, giving it a broad coverage, looking at how he applies it in many different fields, will then help us to figure out how to apply it to our field. Okay, here we are at the end of chapter 17, talking about ionization. There have been many instances in the preceding pages in which a limiting magnitude of the particular physical quantity under consideration has been shown to exist. We have just seen that the number of units of electric ionization of an atom is limited to the net equivalent number of units of effective electric rotational displacement. For example, the element magnesium, which has the equivalent of 12 net effective electric rotational displacement units, can take 12 units of electrical vibrational displacement, or ionization, but no more. Similarly, we found that the maximum rotational base of the thermal vibration in the solid state is the primary magnetic rotation of the atom. Most of the limits thus far encountered have been of this type, which we may designate as non-destructive limits. When such a limit is reached, further increase of this particular quantity is prevented, but there is no other effect. We are now dealing with a quantity, the total outward speed displacement, which is subject to a different kind of a limit, a destructive limit. The essential difference between the two stems from the fact that the non-destructive limits merely define the extent to which certain kinds of additions to or modifications of the constituent motions of the atoms can be carried. Reaching the electric ionization limit only means that no more units of positive asterisk electric charge can be added to the atom. It does not in any way imperil the existence of the atom. On the other hand, a limit that represents the attainment of equality with a basic motion of the atom has a deeper significance. Here it should be remembered that rotation is not a property of the scalar motion itself. It is a property of the coupling of the motion to the reference system. For example, the basic constituent of the uncharged electron is a unit of inward scalar motion in space. This motion per se has no properties other than the unit inward magnitude, but it is coupled to the reference system in such a way that it becomes a rotation in the context of that system, retaining its inward scalar direction. When the electron is charged, the coupling is so modified that an oppositely directed rotational vibration is superimposed on the rotation. The charged positron is a unit inward motion in time, similarly coupled to the reference system. Okay, we kind of referred to that a little bit before with the balloon analogy. When you have, like, say, the inward motion of that balloon with the dots on it, and every dot is moving toward every other dot, there is no direction. Every dot is moving toward every other dot. So every dot is basically moving in every direction. But if you arbitrarily decide to assign a reference point to one of those dots and say this particular dot, we're going to say that this particular dot is stationary, then all of a sudden you can impute directions to the other dots. it will actually appear as if there is a field, gravitational attraction from your dot to all the other dots, that your dot is actually attracting all the other dots because they are now moving toward your dot. But that is not something that comes from the scalar motion. It comes from the assignment of a reference system. So the direction is a product of the reference system, not of the motion itself. And that force field that you're seeing is fictitious. There is no force field involved. The gravitation Larson refers to as an as-if force. So it looks like there's a force, and it behaves like there's a force, and even mathematically it behaves like there's a force. But there isn't. Every dot is pursuing its own course, moving toward every other dot. But since you've decided that there is one reference point, it all looks like they're moving toward that dot. But they are also moving toward each other. So, just to clarify there, again, if you want more of a rundown on the reciprocal system, watch one of my first 474 videos on the subject. Okay, when brought into proximity, a charged electron and a charged positron are attracted toward each other by the electrical forces. When they make contact, the two rotational vibrations of equal magnitude and opposite polarity cancel each other. The oppositely directed unit rotations do likewise. This eliminates all aspects of the coupling of the motion to the reference system other than the reference point, reducing the particles to radiation and bringing them to rest in the natural reference system. As seen in the spatial reference system, they become two photons moving outward in opposite directions from the point in the reference system at which the neutralization took place. Now, just to review again, Larson's system is much of it is based on reference systems. There's a spatial reference system, which is stationary, and a temporal reference system, which is also stationary in time. But then neither one of these reference systems can really account for many phenomena, and they are limited reference systems. Larson also has what he calls the natural reference system. And the natural reference system, the system that nature is actually using, is a moving reference system. This is what Larson calls the progression. The progression is moving outward, and that is the natural reference system at a speed, which is the speed of light, which is 1 unit of space per 1 unit of time. Remembering that the universe is quantized. You have to have a full unit before you have anything. And so 1 unit of speed is a unit of space over a unit of time. Just like 1 unit of matter would be 1 unit of space, 1 unit of time to the third power over 1 unit of space to the third power. Or unit of energy would be 1 unit of time per 1 unit of space. So everything is quantized. The units are quantized. Space and time and motion are quantized. And speed, the speed of light, is a unit of speed. And that is the speed of the natural reference system. That is the speed of the progression. And that is the source of everything. And that is the reference system that nature uses. So that's where Larson takes his measurements from. What is your speed as related to the speed of the natural reference system? Okay. This neutralization, and therefore, your photon, it appears to be moving outward at the speed of light to us from our spatial reference system, our stationary reference system. But from the standpoint of the natural reference system, the photon is actually motionless. It is not moving in reference to the natural reference system. Okay, so this neutralization or annihilation process becomes more difficult to accomplish as the particles increase in size and complexity, and takes place on a significant scale only in the subatomic range. However, full units of the magnetic rotation of the atoms, of the atom units of inward rotational speed displacement can be neutralized by a combination with outward displacements of equal magnitude. The outward motions available for this purpose are ionization and thermal motion. When the total displacement of these motions reaches equality with that of a full unit of the magnetic rotation of an atom, or any full unit of that rotation, the existence of the rotational unit terminates, and its speed displacement reverts to the linear basis, radiation or kinetic energy. As we saw earlier, the thermal ionization level is related to the temperature. The total outward speed displacement at which neutralization occurs is therefore reached at a specific temperature, a destructive temperature limit. Full ionization is attained at a level far below this limiting temperature, inasmuch as it is the total outward displacement that enters into the neutralization process rather than the thermal motion alone. The temperature of the destructive limit of an element depends on its atomic number. The heavier elements have more displacement in the form of ionization when all are fully ionized, and these elements therefore reach the same total displacement at lower temperatures. When the temperature of an aggregate arrives at the destructive limit of the heaviest element present, this element reduces to one with less magnetic, therefore two-dimensional rotation. The difference in mass, T to the third over S to the third, being converted to its one-dimensional equivalent energy, T over S. So that's basically your E equals mc squared. Energy, T over S, equals matter, T to the third over S to the third, times c squared, the speed of light, to the second power. The speed of light being S over T. And the S over T to the second power cancels out two of the T's and two of the S's and leaves energy, T over S. You can use that process for all of your classical equations. You can sub in the T over S terms, to determine the validity of those equations. As the rise in temperature continues, one after another of the elements meets the same fate in the order of decreasing atomic number. Okay, so Larson is referring there to the destructive limits of matter, and he uses this then in volume 3 of this series, The Universe of Motion, his book on astronomy, or one of his books on astronomy, that is how a star burns. Stars burn in Larson's system, not from the bottom up, but from the top down, meaning not from converting hydrogen to helium, but from burning the heaviest elements. The heaviest elements are burning in the center of the star. The star is using gravitation. The heaviest elements sink to the center. And at the center, the temperature, because of the high pressure, the temperature gets so high that it reaches the destructive limit of matter. And the heaviest elements begin to destroy each other or destroy themselves. And each element has a specific temperature that it is destroyed at. And as the temperature, the higher the element, the lower the temperature. And so as the star gets hotter and hotter, more and more elements become subject to that burning process. So that's just kind of a sneak preview of Larson's book on astronomy, The Universe of Motion. Now, I don't believe that we're going to go through that book in its entirety. It's quite long, and some of it is very technical. It's kind of along with a lot of Nehru's work and some of Larson's work. I would classify Universe of Motion along with part of this work as well, but I would classify Universe of Motion along with a lot of Nehru's articles to be kind of like graduate school for reciprocal system, like it's kind of advanced, that you don't really, that you really have to really go pretty deep into the reciprocal system to be able to understand what they're talking about there. With the reciprocal system, even the elementary stuff is pretty hard. So we're going to defer studying the Universe of Motion for a little while, along with the fact that Dr. Bruce Perret has a pretty thoroughgoing critique of a lot of Larson's stuff in there, including some very fundamental stuff like the gravitational limit and the distance between stars in the galaxy, the distance between what we're actually looking at when we're looking through a telescope. Perret adopts a lot of the work from the Iranian astrophysicist Bahram Qadari, if I'm pronouncing that correctly, where he's really saying that all of the galaxies that we see up in the heavens, they're all within like 3,500 light years from us. So everything is super tightly packed in compared to the billions of light years away that we thought we were looking, that everything that we see up there is actually pretty darn close to us, and that space travel is possible. The Andromeda galaxy that we thought was 200 million light years away, or 2 million light years away, is actually like less than 1 light year away, or something like that. So a lot of that work has caused me to reevaluate some of Larson's work, and I honestly am marinating on that, and I really am ambivalent about it right now. I don't really know how to think about it, and so until I maybe go back and read Universe of Motion again and read it in light of a lot of Perret's work, it doesn't necessarily nullify Larson's thinking on the topic, but Larson brings, some assumptions to the table. Again, just like in this work or in his work in general, he is relying on, the scientific tables for his comparisons. And so he's kind of, and when Larson comes up with terminology, then he matches the things that come out of his theoretical universe. He matches them up with things that have already been discovered by legacy science. So if Larson comes up theoretically, he's like, oh, well, this is theoretically there should be this thing that is a rotating unit of space. And then he, says, well, according to legacy science, that would be an electron. So then he labels it an electron. So in a certain way, Larson is relying on legacy science to at least be in the ballpark with things before he makes his identifications. And he does that to a certain extent in the book on astronomy. And so, Perret is kind of tearing that whole edifice down. And I'm going to have to kind of reevaluate that over time, and I don't have time for that right now. So we're not going to get into studying Larson's astronomy, even though that's my favorite book of his. I mean, that is his book on astronomy was my favorite works, and so I struggled through to understand Perret's critique of it, and it's kind of left me reeling. I've been reeling about it for a few years now. And haven't really gone back and revisited it. I'm still trying to kind of figure it out. And there's also, questions about the shape of the Earth. I'm not a full flat earther, but hollow Earth theory is definitely compelling, and even platonic solid shaped Earth it has some allure to me, and I honestly don't know. So I'm going to try. I'm trying to figure it out. That doesn't have anything to do with anything that we're talking about right now. But we just finished chapter 17 on ionization, and tomorrow we're going to start up with chapter 18, which is called The Retreat from Reality. And stay tuned for that. Thanks for tuning in today, and have